I've shared the link, the slide. Yesterday, we were looking at dependencies, activity lists. Can you see my shared screen?
Yes.
The precedence relationships. And this is one. This is one of the favorite questions in PMP, because they want to understand whether you understand the difference between. We discussed this, of course, yesterday. I just want to know whether you still understand FS, SS, FF, finish to finish. Then you have SF, that's start to finish. I think there are 4 precedent relationships. From the PMP page 190. Now, what you need to do here is to just know an example. For example, can you give an example of FS? If you've used a software like Microsoft Project, you will see that by default, all tasks are configured to be FS tasks. So if you have task A, this is task A. It means that it must finish. This must finish before you can start task B. For example, you have to finish the foundation before you start bricklaying the walls. Okay? This is the FS dependency. Then you have the SS. This one means that task A, if this was task A, you must start task A in order to start task B. So what this means is task B cannot start when you have not started task. Task B can start as long as you've started task B. Task B can start as long as you've started task A. This is the SS. Okay. The FF, finish to finish. This one means that if this was a task A, task A must finish, task A must finish before you can finish task B. This is task B, okay? I hope it's making sense. Then, for example, the inspection of the odd premises, you can't complete until all goods have been removed from the building. So if this task was inspection, we cannot finish until we have finished task B. This is FF. Then the last one, which is quite rare, this one SF is very rarely used. It means that task A cannot finish. Task A cannot finish until task B has started. This is the one we gave an example yesterday, like shifts. When you have shifts for security guards, if the security guards are working the day shift, they can't finish until the night shift team have started. This is the SF. SF dependency. You might get sporadic questions in the exam.
Doctor.
Yes, please.
What you're indicating is FS.
SF.
SF is the
start to finish. Start to finish.
But you're showing finish to start. In the,
this is SF.
Yes. That one is okay.
Yes.
But what you've sketched is different from SF. Because A is ending and B is starting.
Oh, so we can change the arrow here. Huh?
Yeah, it should have come from
like
the
this.
start of A.
Like this.
The
arrow
start
should point, because what we are saying is B can start after A has finished.
It is B can finish after A has started.
Are you talking about this one?
Exactly. Exactly.
This one
because you can,
is start to finish.
Mm.
It's called SF, which means that task A can't finish before task B starts. The example I gave is if you have security guard working during the day, they cannot finish until the night shift starts. So you are right, the arrow should point to this. This is like task A. This is the day shift. And task B is the night shift.
Okay.
So the arrow should say task A cannot finish until task B starts. So the arrow should point this side. This is task B. And the example I gave was if task B is night shift, because task A must hand over to the start to finish, which means that the dependency means that task A can't finish until we start B. This task A cannot finish until we start task B. That's the meaning of start to finish. Start to finish. So, which means that this task A should finish when B has started. I don't know whether I'm making myself clear. Then FF, it means that this task, if this was task A must finish when task B has finished. So actually this will go up to the end here. The example here would be that For example, you cannot finish painting unless you have removed all the goods. Unless B has finished, then you can finish painting. Finish to finish. So in order to finish A, we must finish B. This one is the simplest because it says you must finish task A in order to start task B. Lawrence?
Yes.
For example, you put the slab, foundation, then you start bricklaying. This one, start to start, means that you must start activity A in order to start activity B. This is an activity B and activity A. Example. S to S example. If B is testing, you are testing, for example, you are testing a program. Remember, you cannot start testing without program. First, people must start writing the program, okay? If they start writing, implementing the code, then you can start testing because there is something to test. Start to start. A process or task must start before you can start B. I'm not sure. Can you give an example in civil engineering? SS.
On our side. Engineer, doctor. Hello.
Hello.
Yes. You just using the example of a building.
Mm-hmm.
When you are working on the foundation. Hello?
For example, you can clear the plot. You start clearing the plot, and you can start trenching.
Exactly, that's what I'm going to say. Setting out and
that would be an example for start to start. And an example for SF in construction.
And it's so much unlikely.
It's very rare, right?
Yes.
This one, S2F, SF. It's like this task must hand over to task B. For example, the builders, they must, before the roofing guys come, the builders must finish before the roofing guys can start. Because the roofing guys, they need the walls, the weight carrying walls, right? They need all the building up to roof level to be done before they can start the roof, if it's the building. So these guys, task B will need a handover from task A before they can start. That's what SF. So before A finishes, then B starts. Or we can say task A can't finish before B starts because there is need for a handover. What have we done? Where are we? What is the existing? Then they can start. Are we all comfortable with dependencies? Because these are questions which, after the exam, you must know that you have nailed the question. Okay. If you are not asking, I consider that you are comfortable.
We are.
Okay. This just that from my experience, I think they confuse lots of delegates, and there will be about 5 questions on dependencies in the exam. So this refers to what we discussed yesterday in the terms of sequencing activities on the project activities. And you need to review the organization as well as the EEFs. These are external environmental factors, as well as the organizational process assets. So you use the tools and techniques such as PDM. This is the precedence diagramming method, where you plot the project tasks according to what should be done first and next. Then yesterday we discussed also what are the leads and lags. Do you remember?
Yeah.
And these are questions which should be like 10 seconds questions, because you can build a lag in between. For example, task A is painting the house. You can build a lag, 1 day lag for the paint to get dry before you move into the house or the building. Before you move into the building, you build a lag here, 1 day lag for the paint to dry. That's a mandatory lag, okay? It's not like it's a preference. That is a lag in between painting and moving into the building. Because the building, the paint is wet, you cannot move into the building, then you do the lag. Then there is what we call the lead. If this is task activity A, maybe this is cleared in the plot. Whilst you are clearing the plot, you can start already trenching, doing the trenches for the foundations. You can task B, which means this is your lag from here to here. Sorry, this is your lead. Yeah, that's your lead. That's your lead. In Microsoft project, this will be plus 1 day, and this will be minus 3 days. If this is 3 days lead. Okay. And then you can determine the activity duration estimate, elapsed time, and effort. And this is the effort we said we can do person days, person months, person weeks, or hourly, hours. Guidelines to estimate activity durations, which will involve work package owners and others who are very familiar with the work or activity. Consult lessons learned and historical information when you want to do estimation of durations. Review schedule management plan. Determine how you want to quantify the work that needs to be done. Consider resource requirements and capabilities. And of course, you can add their availability as well. Review the resource requirements for each activity. Check the resource calendars for when resources are available. This is very key. I find it very key, this one. This one. Because I might be good at doing something, but then I'm not available. When the project manager wants me, I'm not available. So resource calendars are very important. For example, in this team, in this session, we are 3, we are 4. You are 3, I'm the 4th one. So we have 4 resources. If we have to do the project, then we have to consult each other's calendars. We need 4 calendars because we are 4 in the team. And you know now in project management, we no longer have human resource. We just have resource. The resource covers people, it covers equipment, it covers any other tools you may need in the project. Okay? Even funding comes as a resource, because if there's no funding, I don't think the project will go ahead in execution, because activities have duration, then they have cost associated to activities. That's why when you're building a schedule, the first thing you do is you remove weekends, you remove public holidays, then you look at resource calendars, availability, before you build the schedule. Consider interactions with other projects and operations. Review the project scope statement and assumptions and constraints. This is important because assumptions may relate to funding cycles. For example, money will be released at the end of every quarter. So we know how the cash flow will be doing when the money has been released, and we know that what will be the cutoff points for invoicing. For example, those who want to be paid in July, they must submit invoices by the 10th of June. That helps in cash flow regulations. So if a contractor submit invoice after 10th of June, then they will be paid in August, because the funding, the cash flow will not allow. So you have to take care of that and review the project scope statement for assumptions and constraints. Review the risk register to consider any risks that may affect resource estimation. Review the resource breakdown structure of resources listed by category and type. Just like we have a lot of breakdown structures. This is CBS. This is the cost breakdown structure when you're trying to do budgeting, okay? Then here we are talking about a resource breakdown structure, which looks like a risk breakdown structure. We have also a risk breakdown structure. So when you're talking about RBS, you need to have a context. whether you mean resource breakdown structure, or whether you mean risk breakdown structure. Use tools and techniques, document the activity duration estimates. Because here, if you have what originally was your WBS, you can easily convert this WBS into a CBS, okay? Because now you have anticipated, expected deliverables in terms of work packages. Now, with PM, with the team, can also do estimates for duration and cost, depending on how many work packages you envisage in the project. So you will do estimates on cost, estimates on duration for each work package in the project. Okay, and it's pretty easy to follow because the what was originally WBS becomes a CBS, cost breakdown structure, and then which means that the aggregated costs will form the project cost, the project budget will be here, because you need to do estimates for this, estimates, then you put the estimates together in order to arrive at what you would call a project budget. The only disadvantage with WBS is it doesn't show you the flow diagram, the precedence, what must be done first and next. So you can use Gantt chart, milestone chart, and do the plan schedule network diagram with dates of how, when, who should be do what in the project. There comes the Gantt chart. The most popular chart is the Gantt chart, which is a bar chart. Schedule information with activities are listed in the vertical axis. So from the WBS, you get these will be your activities. These will be your activities. And then you will have, for each activity, you can have start dates and end dates, duration and order. And if you scroll, this is actually Microsoft. I think it looks like Microsoft project, yeah. Which you can enter some precedence relationships. For example, FS, finish to start, you enter the raw numbers of predecessors. And this one is showing you a milestone chart. In the software, whatever is a diamond symbol is a milestone. This is a milestone. That's a milestone. That's a milestone. No, this one is a milestone. This one is a milestone. And that one is a milestone. What is it called? Completion. Is it future past tense? Or normally when we describe a milestone, we use past tense. For example, the charter has been signed off. And what is interesting is, this is an exam question. What's the duration of a milestone? The duration of a milestone must be, can I ask you a question? What's the duration of a milestone?
0.
Very good. Very good. A milestone has got 0 duration, and this is, it's also acceptable to have a past tense. to refer to a milestone. And what you see now here is a project schedule network diagram with dates, assigns start and finish date for activities. And you have for each activity, for example, this is an activity. TF is total float. What is float? Float is the same as slack. Okay? Float has the same meaning as slack. And in a network diagram like this one, where float is late finish minus early finish. Late finish, you subtract early finish. Okay, and if you get 0, then that activity is lying on the critical path. What's the critical path? This is the longest path in the network of activities of a project, because it's all about activities and the duration. So this activity duration is 10. If we take 10 days plus 15, what do you get? 25. Now, you go this way or you go this way. This is already calculated. We have what we call forward pass and backward pass. And now if you say you have a total float, which is 40 minus 40, 29, 48 minus 37, and 61 minus 50. This is the answer. Now, if you go down here, you get the answer 0. 41 minus 41, 0. 61 minus 61 is 0. And the total float is 0, which means that your critical path in this project will be where you have 0 float. This will be the critical path. And now the question is why? Where you have 0? It means that the 0 means that you do not have the luxury of delaying that task, which is sitting on the critical path. And this is why when you are planning the schedule, you need now to consult what? What do you need to consult? What do you need to consult when you are scheduling?
Risk register.
Very good. It's not a by the way thing, it's mandatory, because you've seen on the network diagram that here we have 0 float. Here we have 0 float. It means we don't have time to delay these tasks without delaying the entire project, which means that when we are planning the schedule, we must populate the risk register about what is plan B. For example, activity F has got 0 float. What if there is something unforeseen happens on activity F, which needs to be delayed? What should we do? So as project manager, you must sit down with the team and ask the team, for example, what can go wrong on this activity? What can go wrong? What can go wrong? What can go wrong? and what can go wrong, and whatever should go wrong goes to the risk register. Agreed? So if I look at your risk register and I look at your network diagram, this must speak to the risk register. The question is, why do we still have projects which are delayed? The risk register is going to have a plan B. For example, if it's a rain season, you are building in the rain season. Suppose it's raining heavily on that day, and you fail to execute activity F. What are the measures you put in place to make sure that activity F is not delayed? Because if activity F is delayed, it's going to impact on activity G and activity F. And eventually your project will be overrun, time overrun, and it will fail. Now, do you agree that it's important to manage risks according to the critical path?
Yes.
Very good.
But also non-critical activities need to be taken care of. Otherwise, they may become critical.
What?
The non-critical activities.
Because here, for example, activity C, you've got 11 days.
Yes.
You can delay within 11 days without delaying the project. Activity D, you have 11 days. Activity E, you have 11 days float where you can delay a little bit without delaying the entire project. However, your answer is also good, or is it a remark that you should watch also these activities so that you do not they do not become critical.
Yeah.
I think that's the whole meaning of critical path, because the term critical means not normal, it's sensitive. So the critical path method gives you this determination. Now, the critical path method, it means that you must determine the float, and where the float is 0 in the method, and this is where you draw the CPM. If you're doing this by software, it's quite easy. But I think in the exam, they want you to work out. They will give you a question and ask you, can you calculate the CPM? Here's an example. Critical path. What's the critical path? That's the sequence of activities that represents the longest path through a project, which determines the shortest possible duration. I hope that it's not confusing. It's longest to complete the project. However, it determines the shortest possible duration. And because it's got 0 float, and in this example here, this one, which is this one, 6 weeks, 3 is 5 weeks, activity 5 is 4 weeks, Activity 6 is 1 week and finished. So the critical path here is 16 weeks, and that's your critical path, the longest path through the project for this simple project. And the next example is showing the critical path activity. Any activities on the critical path, any activity on the critical path in the project schedule. So when you calculate total float of 0 is early start and late start. Then you talk of early finish and late finish, which you have here indicated. This is early finish versus late finish. Or if you want to subtract 10 minus 10, 25 minus 25. Okay? And 41 minus 41 is 0, 0. So we can draw a line here coming to here. That's your critical path. Float, that's the amount of time an activity can be delayed from its early start without delaying the project finish date or consecutive activities. And that's indicated 2 weeks float for activity 4. The total float, however, this is the amount of time that a scheduled activity can be delayed or extended from its early start date without delaying the project finish date or violating a schedule constraint. This is just looking at now the definition. Who knows? They might ask you to define a total float. What is a total float? And we should be able to calculate it vis-a-vis the free float. This is the amount of time that a scheduled activity can be delayed without delaying the early start of the successor, of any successor, or violating the schedule constraint. Because if you look at activity C, the successor is D and the predecessor is B. So another activity S, this one, activity H, the early start is 61 and minus activity E, early finish, which is 50, which gives 11. Free float for activity E is 11. So we have 11 days, in other words, 11 days in which we can start activity E without affecting activity H. That's the understanding. In practice, this could be, especially in building, where sometimes you have legislation that you must publicize for 14 days, for example. 14 days you are waiting for public comments on what you are building. So you can delay 14 days. I'm just giving an example without affecting the next activity. Agile release planning.
Sir.
Yes, please.
So how do we calculate these floats? If you're asked to calculate float, is it using that formula?
Very good question. If you are asked to calculate the float, Remember, float and slack is the same thing. Eh? The float, normally you will calculate let finish. Oh, sorry. You will say let finish, subtract early finish. The answer you get, if it's the answer you get is 0, it means that activity is sitting on the critical path. That's you are trying to calculate your float. You use that formula, and if the answer is 0, then that activity is critical. If it's not 0, then that's your float, which you can, amount of time you can delay that task without affecting the project completion time.
Doctor?
Yes, please.
It can also be calculated using late start minus early start. Gives the same answer.
Let's start.
Minus
Yes.
early start.
Yes, that's correct. Are you okay, Ezin? Now, this is not over, because I think they may want you to calculate the critical path. How long is the critical path? Where you apply what we call forward pass, and backward pass. Are you familiar with this? How do you calculate these values? For example, this one, this early start plus duration gives you early finish. For example, 25 plus 4 gives you 29. And 29th day is the early start of activity D plus duration of D, 8. 8 plus 29 is 37. Okay, so on the 37th day, they will constitute the early finish, which will be automatically the early start of activity E. The early start of activity E plus the duration will give you the early finish. So 37 plus 13 gives you 50. Okay, and 50, why is 50 not here? This is the question, because this is the forward plus. Now, which is, you have to take which one is bigger, 50, and the early finish of activity G is 61. Which one is higher? 61. This is why 61 goes here in activity H.
Sorry, I lost you for a short while. Why are we moving 61 up there? I lost you for a short while, sorry.
Why do we have?
No, I'm just wondering what we're doing now. I lost you for a short while.
Okay. Lawrence and Martin, are we together?
Yes, we are together.
You have no issues with the forward pass and backward pass?
Yeah, okay. You are doing the forward pass now.
Yeah, the forward pass. Okay.
Yes.
Maybe this example is not very good because it's got worked figures. Let me just see. No, this one is not very good. Let me use one of my other lectures slides. to explain this, because this one, I'll change the slide so that I use another slides I used in a different course, but about the same thing. Maybe this will be more understanding. Can you see the new share I have done?
Yeah.
Okay. I think I'll start from here. I'll start from here. How to identify the critical path, huh? And this will be, it's about the same thing, but I think I like more these slides, the one I use about the same thing, because the PMP slide are not explaining this. Ezine, you need to understand what they call forward pass. Do you watch rugby, Ezine?
No, I don't.
What?
I don't.
Oh, you don't. Okay. In rugby, there's what we call forward pass. Actually, you get penalized if you pass the ball. All passes in rugby, they are backward passes. You have to pass to somebody on the back who is behind you. You can't do a pass on the forward, somebody who is ahead of you. Anyway, I was just saying it has nothing to do with rugby, but it's just that they call it the same name in rugby, forward pass. Then the referee will penalize you if you do a forward pass. But here in the network diagrams, there's what we call forward pass and backward pass. Okay? So we do calculations of early start and early finish dates. We go forward pass like the term forward. We go forward until the end of the project. Then from the end of the project, we calculate going to the start of the project. We call this the backward pass. Then we can do the float. But the other example in the slide, it had already worked example, so it didn't offer a good explanation. Okay, but in the exam, they might ask you to do a forward pass and backward pass, so you can calculate the float. Before you calculate the float, you need to do already the forward pass and backward pass. Then you can calculate the float. And you can use this as a key. Early finish, late start, late finish, and early finish. And this is your duration. And whatever you calculate here becomes your float. So if you go in the exam, as in, they take a blank sheet of paper, a pencil, and draw this, because it will guide you. Draw ES, early start, LOS, late start, LOF, late finish, and EF, early finish. What some exam delegates do is, because in the exam, they don't allow you to carry formulas or anything, but they can allow you a blank sheet of paper and pencil. So when you start the exam, before you start answering, you put all your formulas down before you forget. You write all the formulas which you'll be using in the exam, because it's, I mean, you go with a blank sheet of paper. When you sit down, write down the formulas. Sorry?
They don't allow anything now.
Even a blank sheet of paper?
Not even a calculator, nothing. Everything is there. Is on the. Not even a blank piece of paper can be allowed.
Serious?
It's because they say that they give you a note where you can write anything that you want as
Where
part
is
of
that
the
note?
on the
Right in the
Yes,
exam.
pardon?
They give the I think he's trying to say that they give you the blank sheets right there. You don't come with your own.
Oh,
No,
okay. Then use the same blank sheets and put the formulas there. Just put the like for example, estimation formula, end value management formulas. Even for scheduling, you can put this. Why not? Because you will see questions asking you to calculate the float. If they give you an electronic notepad, write there the formulas in the notepad.
we get him.
Yeah. And it just be to make so that you don't think about everything. Write everything there. Then you start. So for example, you know that to calculate the float, you need to do forward pass and backward pass. You need to do this one and this one. Okay, so the next example is showing what is the forward pass. You add duration to the highest, using the highest value when activities merge. What does it mean? It means that if this is an activity, okay, and you have another activity here, another activity this side, if this activity is a predecessor of that activity, and this one is a predecessor of this activity, then you must take the highest between this one and that one. For example, if this was 2 and this was 3, then you're going to take 3 here, the highest, because you can only start on day 3, which is higher than this one. This is what they mean here. Then on the backward pass, you subtract duration and you take the lowest value when activities merge. That's all there is to it between forward pass and backward pass. But you need to practice to get this under your belt. So look at this network diagram. You put the slab, install the container, you start doing the shelves, okay? Whilst you are doing the shelving, you can be installing electricity and computers. And then you stock the books. This is, I think, a library, a project to create, to develop to build a library on the container. A container, which is a library. The container will sit on the slab, and then you do shelves and install computers and electricity. You stock the books and get the sign off. So the forward pass will be, you take this 0 plus 5. Here you have early start and early finish. So 0 plus 5 is 5, okay? You add the duration. This is the 5th day on which you can start the installation. You can start the installation on the 5th day. Plus 4, you get 9. On the 9th day, this is where you can start shelves, making shelves. That's why you take 9 there. Because on the 9th day, you can start installing shelving, which will take 2 days. 9 plus 2 will give you 11. Okay? Now, here, whilst you are installing on day 9, you can start doing electricity again. Day 9 plus 5 gives you 14. So 14 goes here because it's the highest. Remember, on this slide, we take the highest. For forward pass, we take the highest value as we take the highest, because We are merging here. We are merging this task here. Installing shelves is merging with this task. Install electricity. So that's why we take the highest, 14. And 15 plus 1 is 15. And on the 15th day, we can get the sign off. 15 plus 1 is 16. So that's your completion date. This is the forward pass. If you want the backward pass, then you have to subtract. 16 subtract 1 day, it will give you 15. Okay? On the 15th day, which is can be copied there, 15 minus 1 is 14. This is now the backward pass. You subtract. The forward pass, you were adding the duration. Then the forward pass, the back pass, you subtract. That is 14 there. 14 minus, 14, yeah. 14 minus 5 is what? Is 9. Now you say 9, and here if we get 14, 14 minus 2 is 12. Okay, 12 and 9, which one is smaller? It's 9. So we take the smallest when going with a backward pass. 9 minus 4 is 5. And this, on the 5th day, 5 minus 5 is 0. So if you want to calculate your float, then you subtract the late finish, you subtract the early finish. So you get your float. Here the float will be 0. Here it will be 0. Here it will be what? 3. Are you there, guys? 15, here it will be 0. Here it will be, if this was 16, the last day, it will be 0, 0, and 0 here.
I'm confused.
So the critical path will be this one. We go where we have float 0 will be our critical path. That's the critical path. And then we add the durations. That's 5 plus 4, 9 plus 5, 14 plus 1, 15 plus 1, 16. That's the critical path.
How did we get 3? How did we get 3?
Which 3? Here.
Yeah.
14 minus 11.
Okay.
So 14 is your late finish, and 11 is your early finish. So it gives you 3. So you've got 3 days. You can delay that task. This one. You've got 3 days in your hand without affecting the project. Because the next activity will only start on day 14. So on day 11, day 12, day 13, you've got that as slack of the float. Okay.
I'm still wondering.
You need to do some exercises. You can ask the question because this is the calculation now. If these figures, now if you look at this, it means they've done already now the forward pass And this is the backward pass we were doing together to fill in the let start and let finish. Let finish minus early start gives you
Okay.
the float.
Okay. So let's start the duration. Add duration is the variables. We add duration. But do
When
they
you're
always
going
give
forward,
duration?
you
Yeah.
start
Do
with
they,
the
do
early
they,
start minus the duration, plus the duration gives you the early finish.
do they always give the duration?
Yes, all
Okay.
tasks must have duration.
In exam, they give the duration.
That's right, yeah.
Okay, so what I
You'll
want
be
to
given
get
something like this. You'll be given something like this.
okay.
You see, duration is given and predecessor is given. From this example, you can draw a network diagram and calculate the backward pass and forward pass.
So the predecessor is A, B, A, C.
You can do this exercise if you want, because this one will give you, you have to start with A. Of course, you can do a start button, but you start with A. They've given you A is 3 days.
Yeah.
Okay. They will tell you the predecessor. For example, B, this task B, what's the predecessor for B? It's A. So this is A. So
Yeah.
we are told that's A and that's B, and the duration of B is
6 days.
6 days. 6 days. Then we are told also that C, the predecessor is A. So we have to go this way and build C. This will be C, okay? The duration of C is 5 days. 5 days, and D, the predecessor is B. So you go this side and do D. That's your D. And they always give you duration. For D is 4 days. The next is E, the predecessor is C. So this our E. Predecessor is E, sorry, this is E. E is 2 days. And predecessor is C. The next one is what? F. F predecessor is D and E. So we can do an F there. Predecessor is D and E. And F duration is 6 days. The next is G, predecessor is B. So we need G, predecessor, this is what? Is B. So you draw G there.
And it's 5 days.
It's 5 days, yeah. And next one is H. The predecessor is G and F.
How do you draw that one?
I was supposed to do, the predecessor is G and F. G and and F. So this is we can do like this. This would be this would be H, and H is 3 days. Predecessor is G, and F, we've got F here, so we can put there as predecessor, then rub this, and draw it here.
Oh, okay.
This would actually be G. G is 5 days. And the predecessor is B. And it's a predecessor of H. Okay? Yeah. So here we've got the network diagram. GF is pointing into H. Yeah. So they are saying use this diagram to calculate, to do the forward pass. And you just know, you know now that here it will be your early start.
Where? Yeah, A.
Early start and early finish. At the bottom, they are all late. Late start and late. This is the early finish. At the bottom, you've got late start, late finish,
and late start.
and late start. If you start at day zero plus duration, then you're going to have 3 here. Okay? 3. Sorry, my mouse is 3, which means activity B can start on day 3. 3 plus 6 gives you 9. Because you can start activity B on day 3, plus the duration is 6 days, then the early finish is 9 days, day 9. Okay? And here on day, which day? Day 3, you can start B. C, you can start task C on day 3. Plus 5, which is 8. Early finish. So this can start on day 9. This can start on day 9. This can start
this
on day 9 plus 4, that's 13.
13.
The duration. And 9 plus 5 is 14. So this task 13 and this one is 8. So we can start on day 8, task E. 8 plus 2 gives us 10. So this task is merging. You see they are merging. Task
That's D and
E. They are merging. So which one is higher? 13 and 10. So we take the highest, which is 13. 13 plus F was 6 days.
19.
19, yeah. So it will be 19 there. This is the fourth pass. 19th day. On the 19th day, F and G are merging. So we take the highest, 14 and 19. So on the 19th day, we can start H.
And end at 22.
22, yeah. So 22, which we write down here, 22, because that's the last day. We subtract now. We finished the forward pass. Now we do the backward pass. Now what's that? 22 minus 3 is?
19.
It's 19. That's the late start. Now 19, we will come this side.
Which side?
On the 19th day, and this side, 19. So 19 minus 6?
13. So we don't pick, oh, the lesser one is 19. It's true.
19, yeah. So we have to do 19 here.
Why 19 again?
Because on the 19th day, this is the 19th, oh, sorry, 13. My apologies. Because 19 minus 6 here will give you 13. So it's 13, which will come, we put 13 there. On the 13th day, as well as here, 13th day. 13 minus 2 should be 11, huh?
11, yeah. So are we?
And here we have 13 minus 4.
Why are we putting 13 there? Because it's
13, because on the 13th day here,
okay.
that is the late start. The late start of this is 13, because 19 minus 6 is 13.
Mm-hmm.
So the late start for this activity is 13th day, which we copy to the predecessor 13th day. That's the 13th day. The late finish becomes the late start for this one. And now 13 minus 4 gives us 9. And here 13 minus 2 gives us 11. And on the 11th day, this is the 11th day becomes the late start, which is the late finish of C. So that's why we put 11 back here. And here we put 9, because 9 is the late start,
Yeah.
which becomes the late finish of the predecessor. 9 minus 6 is 3. Okay.
What about G?
And G is 19 minus 5 is what? This side is 14.
14.
On the 14th day, this is merging. This is so we take the lowest between 9 and 14. Remember, backward pass, we take the lowest because they are merging. That's why we take 9 here. And 9 minus 6 is 3. And then we take
3.
And this one is, what was this one? Was 11 minus 5.
11 minus 5 is 6.
Very good. Now, which one is smaller? Because they are merging this task. When they are merging, we take the smallest when we are using backward path. So 3 and 5, we take 3.
Okay.
We take 3, and 3 minus 3 is 0.
Which ones are merging?
This task here,
B and C.
B and C, they are merging into A.
Take 3. Yeah.
So we take the smallest. On the late start is 3 days, and here the late start is, I think, 5 days.
Yeah.
So we take 3, the smallest, when we are going backwards. And then we can calculate the float now. 3 minus 3 is 0. 9 minus 9 is 0.
Hold on. The float is late finish minus early finish.
That's right.
Okay. 0. This is 0, 0, 0, 5.
Here we have 3.
0, 0, 3,
3.
2.
And here we have 3. 13 minus 10.
3.
Here we have 19 minus 19.
0.
0. and here they are 0.
E is 3.
Here is
C is 3. No, it's 3.
here is 0.
Where?
C is 3, yes, and here it is 19 minus 14 is 5. Eh?
Yeah.
Here is 5 float.
Mm-hmm.
Okay, and there is 0. So the critical path will be this one where there is 0, and this one, and this one, and this one. So we have to add now. We say 3
Plus 6.
3
plus 6 plus
6
4 plus 6
plus
plus
4
3.
plus
Hard.
what 6, right?
6 plus 3.
Plus 3, yeah. This is your critical path.
That's a lot of hard work. That's 22.
Which gives you 9 plus 19, 22.
This is more than
22 days. So they will give you something like this to calculate the critical path, and where float is 0 gives you the critical path. And
I understand it better now.
okay, so the answers can be like A, 22, B, 29, C, 19, D, 15. Then they will tell you what's the critical path. And from the project management point of view now, then you say that all these activities which are on the critical path must go to the risk register because the float is 0. So we must be very sensitive, very careful that we do not delay the project. Okay, then we go back to the slides. This is what, because this one was already worked out, so it was very difficult to explain in terms of early finish and late finish for your float. We are okay now, isn't it?
Yes, I
Just
am.
need to do 1 or 2 more exercises, then you'll be fine. Then the next is agile release planning. This is
before we get to agile.
Yes, please.
How about a scenario where we have conditions
Where we have
on those conditions set by maybe management or on the dependence or where they dictate this must start this time, this should start on such and such a one if they put such condition. Do you have an example? Because what you've gone through is the simplest, but now do they bring conditions where such conditions are put?
Yeah. Hello, Martin.
Hello. Yes.
Yes.
Did you understand my concern?
You were breaking, but if I understand you correctly, you are saying that a schedule with management conditions like start date, end date. I don't know.
Yes.
They can put in things like lag and lead.
Yeah, I think.
This is why I put this different slide, which is explaining. The only thing they can put in is what we call when there is a lead, there is an overlap. When there is a lag, there is a waiting time. This is what they can put in between tasks. If there is a lag, then you account for the lag time. This is the finish date, and this is the start date for task 2. If they tell you there is a lag, then you have to accommodate the lag. If they tell you there is a lead, then you have to push, that's the lead inside here. Then it will just affect the start time. The start time may be affected. But if you draw for yourself this, it's quite clear that lead is what is actually subtract. And lag is you add 3, for example. If it's 3 days lag between task 1 and task 2, then that will, you just have to change the start date. But in a schedule, okay, yes, why not? They can add lag and lead in the schedule. So just know that if there is a lead, there is an overlap, or in terms of start date. And this is why even in Microsoft project, we do, it will look like this. In project, it will look like this. The finish to start is always the simplest. We must finish this task before we can start this one. The start to start, as long as we've started this one, we can start this one. E, this is an examples of start to start, finish to finish, which means that for us to finish this one, we must finish doing task B. For example, in order to finish painting, we must remove all the goods from the room. We must finish removing the furniture so that we can finish painting, finish to finish. Here we have a lag. You see, lag is a plus because it adds to what we have. Then lead is you subtract lead of 3 days, because this will be 3 days from here to here. And plus here we have 4 days lag. We add 4 days for which one is start to start. We need to wait for, before we can start task B, we need to wait 4 days here. This is the only thing they can add in a question to maybe make it more interesting. But just follow the date. And predecessors are very important here in the net for critical path, this column. They will give you this and duration. Yeah. Then you can work out the forward pass and backward pass, and you should be good to deal with these questions. These are the questions when you read the exam, you say that, no, I think I've hammered those questions, because the calculations should be, yes, should be easier than theory.
Yeah.
So if you look on the agile side, remember a release, what's a release? Release plan contains, a release is just a container of finished products. for lack of better words. You have a product vision drives the product roadmap. In Agile, we relate to a vision, what we call envisioning of a product. Product roadmap drives the release plans. We need release plans because sometimes you can finish a product incrementally. For example, we finish these products, but the market is not ready. So what do? We package them into a release and wait for the market to be ready. For example, if there are some promotions which work well during Easter, there are some promotions, some products which sell during holiday festive season, especially the fintechs, technologies, payment solutions, and promotions. They go with season, with consumer appetite, consumer behavior. So people, we have like release planners. If you like, you can say we have a backlog of release backlog. That's a release backlog. And here you should plan like release 1, release 2, release 3. But these releases should not affect the Agile team. The Agile team don't care about releases. They care about user stories, the tasks. You see what we were discussing yesterday? This is user story 1, user story 3. Each user story is refined, decomposed into a task and given to a specific resource. And this will be an iteration plan is as good as a sprint. I think PMI is very careful. They don't want to use the word sprint because when you say sprint, you are referring to the Scrum guide. It's about Scrum. Scrum has got daily stand-up, sprints. These are Scrum terminology. Scrum as an Agile framework. But when they say iteration plan and sprint plan, it's the same thing. It's just terminology. Iteration plan. It's also a time box. For example, this is a time box. Iteration 0 is a time box. That's a time box. That's a time box. These are sprints, which should be between 2 to 4 weeks. Okay? Max 4 weeks. You can't have a sprint 2 months or 1.5 months, never. Then that's something else. Okay? 2 to 4 weeks. But for high-risk projects, you can have a sprint even 1 week, even 1 day. Why not? But normally it's 2 to 4 weeks. And you can have a release manager to be planning, doing the release planning. That's the release planning, which establishes iterations in a release and which go to the market. These releases now they go to the market. You can also liken this to if for estate developers, those who develop residential, they can buy a farm, demarcate the farm, and start developing living complexes. They develop a complex as a release. They put tenants there. Then they start planning for release 2, another complex. Dwelling, for example. And they can easily use the rentals as value from release 1 and fund the next complex. So ongoing progress based on methodology, measuring the project's progress with respect to the schedule consists of monitoring the status of the project to update the project schedule, because the schedule baseline is also approved. The reason we approve the schedule baseline is we want to know what are the delayed tasks and why they are delayed. And if there is a change request, then we must before we change the baseline, the schedule baseline, we must create a snapshot of the baseline and keep it away. Because in the closure report, project closure report, we must be able to have the final schedule compared to the baseline and what has changed in the project, and that can create lessons for future projects. And this is why we must keep the baseline, not overwriting it with change requests. In an agile approach, we evaluate progress by comparing the total amount of work delivered and accepted to the estimate of the work to be completed. And this is where we use reviews of completed work in regular sprint demos. A demo happens when the sprint finishes, then we need to do a demo. A sprint review is a formal demo. You must write somewhere. This is very important. What we call a sprint review is very formal. You can invite stakeholders, do minutes, but the retrospective is informal. This is informal because this is for the team to learn. So when the team is doing a retro, they normally learn and laugh about the mistakes. There should be no boss invited in a retrospective because people will not speak honestly when there is a boss around. So
hello, sir.
Hello?
Yeah. So you said sprint review is a formal demo.
That's right, yes. And minutes must be taken, stakeholders must be invited officially. That's a sprint demo. It's a very formal. It's like a milestone. Yeah. Sprint demo is very formal. You have a PM, you can even have the steering committee, technical committee. They should come and look at the demo. And that demo also acts as a report, progress report. Demo itself is a technique in which we do, because when they see a demo of a product, it's like a progress report. And also you can pay contractors after the demo. It could be a design demo, and you can get even approvals after the demo. Whereas the retrospectives is not formal. It's informal, but it's for the team, for peers. It's like a peer review to retrospect what went well, what didn't go well, how to do it better next time. Determine the rate at which the deliverables are produced, validated, and accepted. That points to velocity, which we discussed yesterday, velocity of the team. And coordination with other products. If the project is part of a program or portfolio, the schedule status of the project should be evaluated for any effect it has on other components of the program. In some situations, a delay, acceleration of a project may not impact other projects. However, if the delay or acceleration is caused by activities on the project critical path, and that project is critical to the schedule of other projects, the overall effect can be significant. And that's why we do scrum of scrums. I'm not sure whether you've heard about this. A scrum of scrums.
For big projects.
For big projects, you will need to do scrum of scrums in agile projects. That's a team. It's normally like a sync meeting. We call that a scrum of scrums. To sync work. For example, if you've got 5 teams working on different products, you will need to sync their work. And to do that, you have to have this ceremony happening, scrum of scrums. So different teams meet in order to sync work. And we call that scrum of scrums. So each team is going to have their own scrum master. And the scrum masters must discuss when to have a scrum of scrums and synchronize work which is being done by different teams. That ends the sequencing activities discussion. And what should be the next is quality. I think quality will discuss it tomorrow. So we finished scheduling, and the next topic is quality. But we would want you to do some exercises this evening. We will liaise offline during with the WhatsApp, whether you can see the simulation questions, and then you can attempt them.
Okay.
Okay, we'll liaise via WhatsApp, but I would want you before tomorrow's discussion, because tomorrow we'll discuss quality, you to do some exercises on scheduling.
Okay.
Scheduling and scope and budget. Any questions?
Doctor,
Yes, please.
tomorrow I may join a bit late. I have a meeting at 9 Central African time.
At 9:30?
At 9 Central African time, I have a meeting and I may join a bit late. But
Okay.
I'll find you going. I'll find you.
All right. Noted. Okay, then. See you later. Bye-bye.
All right.